In this class, we will talk about the trigonometric identities. These identities are very, very important as they will help us in the algebraic solution of the trigonometric ratios. So the first one we are going to talk about is the sum and difference of positive angles. The sum and difference of positive angles. And the first one we'll talk about is the sine A plus B. Whenever you're given a trigonometric identity to solve and it includes the addition of two angles, this is how you're going to do it. As far as sine is concerned, we'll have sine A plus B, where A and B could assume any angle whatsoever. So sine A plus B is equal to sine A cos B plus cos A sine B. So if I have sine 105 degrees, if I want to solve sine 105 degrees without using table or whatsoever, so what I'll just have to do is to split 105 into 2. And you agree with me that 105 is sine 60 plus 45 degrees. So to evaluate it, I have sine 105 degrees equals sine 60 plus 45 degrees, which is equal to sine, let this be A and this be B. So this will give me sine 60 cos 45 plus cos 60 sine 45. And you can solve these further. Is that okay? So this just shows us, I just did this so as to show you how to apply the first one. And the same thing, the same method will be followed in the subsequent trigonometric identities. Is that understood? The second one to consider is cos A plus B. And cos A plus B is equal to cos A cos B minus sine A sine B. Alright? So the third one is, if we have the difference, both the first and second one shows addition, that is the sum of the positive angles. But let us look at the difference of angles. So we have sine A minus B will be equal to sine A cos B, then minus cos A sine B. So this shows the trigonometric identity for the subtraction of A and B. Now let us consider the fourth one, IV. We have cos A minus B, which will be equal to cos A cos B plus sine A sine B. Right? So the fifth one is the tangent of the two angles A and B. So let us consider the addition first. So tan A plus B is simply equal to tan A plus tan B all over 1 minus tan A tan B. And what if we are asked to subtract A, B from A? We have the sixth one, which is tan A minus B, and is equal to tan A minus tan B all over 1 plus tan A tan B. Okay, so these are the set of angles that shows the addition and the subtraction of the angles. Let us consider the multiple angles before we wrap it up for this section as well. So multiple angles. For the multiple angles, we have, let's make this the first one here. If you have sine 2A, sine 2A would give us nothing but 2 sine A cos A. So we have probably sine 2 theta, where theta could be any angle. So to solve it, it will be 2 times sine theta cos theta. Okay? So if theta is 60, so we have sine 2 theta, which is sine 2 times 60, equals 2 times sine 60 cos 60. Of course, the left hand side must be equal to the right hand side. You can check that by assuming that A equals 60 degrees. You can check that. Alright, so the second one is the multiple angle cos 2A. Cos 2A will be equal to 2 cos square A minus 1, or is also equal to 1 minus 2 sine square A. So cos 2A would be equal to 2 cos square A minus 1, or 1 minus 2 sine square A. And how do we get this? Let's make that our third identity. Or let us say, note that sine square A plus cos square A equals 1. Therefore, since cos square A is here, if we make cos square A the subject of the formula in this equation, then you have that cos square A equals 1 minus sine square A. If you put this equation inside this equation, you have that cos 2A will be equal to 2 times, because cos square A is no longer cos square A, but 1 minus sine square A. So we'll say 2 times 1 minus sine square A, then minus 1. Of course, if you open the bracket, you have cos 2A is equal to 2 minus 2 sine square A minus 1. So therefore, 2 minus 1 is 1. I have 1 minus 2 sine square A, which is the same thing with what we have over here. Is that okay? So that is that. One of my teachers say that a lot. That is that about that. So I have the third identity to be equal to sine square A. Of course, sine square A equals 1 minus cos square A. We've said that in the second identity we considered above. So the fourth one here is tan 2A. Tan 2A, which is equal to 2 tan A over 1 minus tan square A. So I want us to take note of all these identities, because they'll really help us when we are to solve problems under trigonometric identities. Now, having said that, we can employ the knowledge of these trigonometric functions or this trigonometric identity to evaluate other functions. Is that okay? Just like we said in our elementary trigonometry, that if we know sine, cos, and tan thetas, we can use it to solve for sec theta, cos theta, and cot theta. Is that understood? Because we already have our background knowledge on those ones. So we can solve for other higher problems. So since we know all those things we've discussed above, we can solve for other trigonometric identities. Now, these will be discussed in our next class. So I want you to go over what we've discussed, and if you have questions for me, you can ask them, and I'm going to attend to them as soon as I see them. I'm always here for you to lead you through the path of success. You've got nothing to worry about insofar as you can stay with us to trash these courses together. So see you in our next class.